Welcome to Alex's ASE podcast, designed to help you ace your A2 automatic transmission certification. I'm Miles, and I'm here with our expert technician and teacher, Alex A1. Today we're going to dive into some common Ase A2 questions, breaking down the answers so you understand not just what's correct, but why.
That's right, Miles. Our goal is to make these complex topics clear and practical, giving you the confidence you need for the exam and in the shop. Let's get started.
Excellent. Our first question revolves around the torque converter lockup clutch. Technician A says a bidirectional scan tool can command the lockup clutch to turn on. Technician B says the engine RPM should increase by approximately 150 RPM when the converter lockup clutch engages. Who do you think is correct here?
This is a great starting point for understanding torque converter operation. Technician A is correct. Many modern bidirectional scan tools include an output test specifically designed to engage the torque converter clutch. This function is incredibly useful for diagnostics, allowing you to confirm the clutch's electrical and hydraulic function without driving the vehicle. Now, regarding Technician B, they are incorrect. When the torque converter lockup clutch engages, it creates a direct mechanical link between the engine and the transmission, bypassing the fluid coupling. This direct connection actually causes the engine RPM to decrease, typically by around 150 RPM, not increase. This decrease is a key indicator that the lockup clutch has engaged successfully, improving fuel economy and reducing heat.
That makes sense. So, a scan tool for testing and an RPM drop indicates engagement. Let's move on to diagnostics. Question 22 asks, Technician A says a misadjusted range sensor could cause a no-crank condition. Technician B says a misadjusted park neutral switch could cause a no-crank condition. Who's correct?
Both technicians are correct here, Miles. A no-crank condition means the engine won't even try to turn over when the key is turned. Both the range sensor and the park neutral switch are safety devices designed to prevent the engine from starting unless the transmission is in park or neutral. If either of these components is misadjusted, the vehicle's computer won't receive the correct signal indicating it's safe to start. This effectively creates a false in-gear signal, and the car won't crank. Most vehicles use one or the other of these, but their function is essentially the same in this context as safety interlock. Their proper adjustment is also crucial for things like backup lights to work correctly.
So both are critical safety inputs. Now for a question about what doesn't happen. Question 23. All of the following conditions will cause the torque converter clutch to disengage except A. Applying the brakes, B. Heavy throttle application, C. Decreasing vehicle speed below minimum engagement specification, or D. Shifting the gear shift into overdrive.
The correct answer here is D, shifting the gear shift into overdrive. Let's break down why. The torque converter clutch, or TCC, is designed to disengage under specific conditions to allow the fluid coupling to take over, like when more torque is needed or during deceleration. Applying the brakes, for example, signals the TCC to disengage because you're slowing down or stopping. Heavy throttle application means the engine needs to rev higher to accelerate, which is best achieved through the fluid coupling, so the TCC disengages. Similarly, if your vehicle speed drops below a certain threshold, typically around 35 miles per hour, the TCC will disengage. However, shifting into overdrive, which is usually the top gear, is precisely when the TCC is most effective. It locks up in overdrive to reduce engine RPM and improve fuel economy during cruising. So it wouldn't disengage then. In fact, it's designed to be engaged.
That's a good way to reinforce TCC function. Let's talk about fluid leaks. Question 28. A vehicle has fluid leak around the bell housing area. Which of the following faults would be least likely to cause this problem? A. Transmission front pump seal. B. Transmission bottom pan gasket. C. Engine rear main seal. D. Transmission front pump retaining bolts.
The answer least likely to cause a leak around the bell housing is B, the transmission bottom pan gasket. The bell housing is the part of the transmission that encloses the torque converter and mates to the engine. Any leak in this area typically comes from components located between the engine and the transmission, or directly within the bell housing cavity. A leaking transmission front pump seal, a leaking torque converter itself, or even leaking front pump retaining bolts, which often require thread sealer, would all result in fluid appearing in the bell housing. An engine rear main seal leak would also show up there, but it would be engine oil, not transmission fluid. A transmission pan gasket, however, seals the bottom of the transmission case, so a leak there would show up underneath the transmission, not specifically in the bell housing area.
That's a helpful distinction between leak locations. Shifting gears, let's discuss sensors. Question 29. Technician A says the TR sensor is used to signal the selected range to the PCM. Technician B says the harness connector can be used to test the resistance of the internal shift solenoids with an ohm meter. Who is correct?
In this scenario, both Technician A and Technician B are correct. The TR sensor, which stands for Transmission Range Sensor, is indeed crucial. It tells the powertrain control module, or PCM, exactly what gear the driver has selected: park, reverse, neutral, drive, etc. This signal is vital for proper transmission operation and safety interlocks. Technician B is also correct. The main transmission harness connector is a common and very practical place to test the resistance of internal shift solenoids. By testing from outside the transmission, you avoid the extensive labor of dropping the pan to get to the solenoids directly. This allows you to quickly determine if a solenoid has an open or short circuit, which can cause shifting problems.
So external testing saves a lot of time. Let's look at component inspection. Question 31. Which of the following statements about bearing preload is least likely to be correct? A. A bearing preload that is set too tight will loosen up once the unit heats up. B. A torque wrench is needed to set the bearing preload. C. Bearing preload is sometimes checked by testing the turning effort of a component. D. Bearings must be lubricated in order to perform under an extended load.
The statement least likely to be correct is A. A bearing preload that is set too tight will actually get tighter as the unit heats up, not loosen. This happens because the materials expand with heat, increasing the pressure on the bearings. This excessive tightness can lead to rapid wear and premature failure. Options B, C, and D are all correct practices. A torque wrench is essential for accurately setting faster tension when adjusting preload. Preload is often measured by the turning effort required on a component, sometimes using a specialized torque wrench. And, of course, all bearings require proper lubrication to function reliably under load. Without it, friction and heat would quickly destroy them.
That's an important distinction regarding thermal expansion. Let's move to a diagnostic test. Question 38. All of the following transmission components are being tested during a stall test except A. Oil pump capacity, B. Band holding capacity, C. Clutch pack holding capacity, D. Torque converter stator.
The component not primarily tested during a stall test is A, the oil pump capacity. A stall test involves applying the brakes, putting the vehicle in gear, and fully applying the throttle to observe the maximum engine RPM before the wheels start to move. This test primarily evaluates the holding capacity of the transmission's internal components, the clutch packs, the bands, and the one-way clutch inside the torque converter stator. If a clutch pack or band slips, the engine RPM will rise higher than normal, indicating a problem. If the stator's one-way clutch isn't holding, the RPM will be lower than normal. However, to truly test the oil pump's capacity, you'd need to perform a separate line pressure test with a gauge measuring actual fluid pressure output.
So the stall test focuses on mechanical holding. Next, another question about hydraulic control. Question 42. Which of the following components is least likely to have an effect on line pressure? A. Governor valve, B. Manual valve, C. Throttle valve, D. Gear selector.
The governor valve, option A, is the component least likely to directly affect the main line pressure in the way the others do. Well, it generates a pressure signal proportional to vehicle speed, which influences shift points and line pressure modulation. It's not the primary adjuster of overall